This time we will cover or discuss about fractional inequalities. This is part of the chapter 7, rational algebraic functions for 10th grade advanced algebra. Before we go to the fractional inequalities itself, let's have an introduction and let's review back about quadratic inequality. Okay, if I have quadratic inequality and this is the problem, x squared plus 7x minus 30 is greater than 0, it means we need to find all values of x which will satisfy this inequality. So if we remember, first we need to factor, if we can factor it, we need to factor this. So it will be x minus plus 10 x times x minus 3. Right? It's greater than 0. And then we find all the zeros. So the zeros of this one will be x1 equals negative 10. And the zeros of the second factor is 3. Okay. How should we find all values of x that satisfy this inequality? Let's just use the number line. Okay, sorry. So now we put all of the like a border. So the zeros will be the border, right? So it is negative. The border will be negative 10, and then the other one is 3. And then since we know that the inequality is only greater than, okay, without any equal sign, it means we just leave the open circle for each of the border, since your solutions cannot be equals negative 10 and 3. And then the rest is just checking the area, right? Testing the area. So let me just review back. So we have 3 different areas that is divided by negative 10 and 3. Let's just check from the middle, since on the middle we have that 0 is our representatives. So if I put 0 into the original or the later, it's fine, but let me just use the original. If I use 0, it will be 0 plus 0 minus 30 greater than 0. So the statement will be negative 30 is greater than 0, will be false. Therefore, all numbers from that area will be not the solution. And we know that, of course, by doing the same, if I use representatives of the left area, for example, negative 15, and for example, from the right area, I will use 10. Okay, you can just put into this equation or inequality, sorry, and then you can find that actually they will satisfy the inequalities. So in the end, your number line will be like this. Sorry, I'm supposed to use the ruler, so I'm expecting you to use the ruler, and then you can shade it like this. Okay, so if I put it in, so the solution will be all x that is lesser than negative 10, okay, and all x that are greater than 3. Okay, so let's just put the number line as your final answer. Okay, that's how you do with quadratic inequality. Keep in mind that first you need to factor, okay, factor the polynomial, and then from the factors find the zeros, and keep in mind that the zeros will be the border. That's how it works. And then the rest you just test the area. Okay, how to test the area? You just need to test one area. For this one, I test only the second area, and then since I know that after I know that this is not this area is not satisfied, it doesn't satisfy the inequality, it means the other area will satisfy the inequality. So next. Now, how about if I have a cubic polynomials inequality? For example, this is the problem. So whenever we have this, first factor it. Okay, let's factor it, the cubic polynomial, and this one you can factor it by factor theorem, of course. Okay, you can use the factor theorem to factor it, and then let's just keep that in the end with the factor theorem. I can know that the factors will be x plus 2 multiplied by 3x minus 1 multiplied by 2x plus 1. Okay, less than equals to 0. So therefore, after we have all the factors, let's just find all the zeros here. So the first zeros will be negative 2, the second 0 will be 1 over 1/3, and the third one will be negative half. Okay, so we have now 3 borders. Let's just put our borders here. So first it is negative 2, this is negative half, this is 1/3. So I don't use the scale here. Okay, and then it's okay. So now, because we have the inequality with the equal sign, it means all of these borders can be the solution, can be. So it will be closed circle since there is an equal sign. Notice the difference with the previous one. So it is close circle, and close circle. Now the thing is, now we have 1, 2, 3, 4, 4 areas. Okay, and the safest one is we test all of the representatives of these four. For example, if I want to use the representative for the first area, we can use -5. For the second area, we can use -1. For the third area, we can use 0. And for the fourth area, we can use 10, for example. So the safest one, just check one by one into the original inequalities and then find which area satisfy that inequalities. Okay, since if one of the representatives can satisfy it, it means all values inside that area will also satisfy it, and vice versa. So let's just use 0. I like 0 because 0 is easy to be calculated. So if I put 0 into this inequality, I will have 0 plus 0 plus 0 minus 2 less than equals to 0. It means the last statement will be -2 less than equals to 0, which it satisfies the inequality. So actually, yes, it satisfies. Okay, so let me just pretend, let me just use -1 as the representative of the second area. So if I use -1 and I put into this inequality, so let me just use, if I use -1, so it will be -6 plus 13 minus 1 minus 2 less than equals to 0. So it will be, wait, it will be 4. 4 less than equals to 0. And it is wrong. It means this area doesn't satisfy the inequality. And then let's use -5. If I use -5, in the end, I will have, okay, this one is tough. Okay, -5. Let me just calculate it directly. I'm using my calculator so we can save time here. And we have negative, what, 432 is less than equals to 0. Okay, so in the end, we know that actually it is a correct statement. Therefore, this area will satisfy the inequality. The last one is 10. So if I use 10, it will be 6,000 plus 1,300 plus 10 minus 2 less than equals to 0. Well, I can believe that this one is a huge number, positive, and it is not less than equals to 0. Therefore, it will be, it won't satisfy. So actually, see, you can see that this one satisfies, this one not, and this one satisfies. Okay, so the last conclusion is, for this inequality, my number line, I'm sorry, I have to remind you again, use ruler. Okay, that is my expectation. So yeah, all values that are lesser than -2 and equals to -2, and all values that is between -half and 1/3 inclusively will satisfy your inequality. They are the solution. Okay, so notice that actually, okay, so here is the practical one. After you have done a lot of things like this, okay, you can conclude that you don't have to check one by one the area. Okay, check only one. Okay, for example, I check the third area, and when I figure out that this one is right, this one is satisfied, this one will satisfy the inequality. So when I'm moving to the, for example, when I'm moving to the right, to the fourth area, I am passing one factor. This one is one factor. Since I'm passing one factor, the sign will change. So if previously it satisfied, so the next one, it won't satisfy. So let's go back to the third one. So if I'm moving from the third to the left, the second area, I'm passing one factor, okay, this factor, -1/2. Therefore, because I'm passing one factor, the sign or the condition will change. Previously, it satisfied. The second one is not satisfying. It won't satisfy. It won't satisfy the inequality. So now, after I have the second area, from the second area to the first area, I am passing another factor, which is x plus 2. because the 0 is -2. So from before it doesn't satisfy the inequality, since I'm passing one factor, it flipped back into satisfy the inequality. So see the pattern here. So actually you can use other method rather than you checking one by one the representative of each area, which is that one is the safest one. Okay, I guarantee that one is the safest one as long as you don't miscalculate. But maybe relatively you can see that it kind of, yeah, you spend a lot of time there to just checking one by one. So instead of doing that, let's just check one area in particular and then using the moving things. And whenever you pass one factor, it will change the condition. So to make it clear, let me just discuss next problem. Now we are going to the fraction inequalities. Now this is the core of our videos. Okay, now we are going to the fraction inequalities. So this is one of the example. This is the simplest one because it is a fraction, a rational algebraic. So this is a rational expression, 1 over x plus 3, and we have only one factor. But the thing about fraction inequalities, it's almost the same with the previous one, which is not a fraction. We just need to factor everything, and keep in mind, actually, with compare with the previous one, we always have the same situation. We make one side into 0. Okay, so that is one of the requirements. Before we go to the factors, we try to find the borders and testing the area. We need to make one member or one side into 0 first. So for this particular problems, we have already had this one. So let's just go to the factors. So we only have one factor, which is x plus 3, and the border is for our the 0 is -3. But keep in mind, since it is on the denominator, we know that x minus 3, x equals -3, cannot be one of the solution because it will make the denominator is 0, right? So it will make the value will be undetermined or undefined. It means no matter what is the sign here, whether it using equal sign or not, -3 cannot be your solution. It means we have one border here, which is -3, but it has to be an open circle, no question. Okay, so don't see the sign of the inequality. It doesn't matter. Whenever you have factors on the denominator, it has to be an open circle since with the solution cannot be equal to that number. Okay, I hope it's clear. So the rest is what? So we need to test the area, right? We need to test the area, and then from the left side it will be like -4 I can use. From the right side I can use 0, the favorite one. So if I'm using 0, okay, like I'm checking to the original one, it means it will be x 1 over 0 plus 3 less than equals to 0, right? So it is 1 over 3 less than equals to 0, which is wrong. It doesn't satisfy the inequality. Therefore, this one is not the answer. So I will just pretend that I don't know the other area. What is it will satisfy it or not. So let me just use -4. If I use -4 into the inequality, 1 over -4 plus 3 less than equals to 0. It means 1 over -1 less than 0. Okay, -1 less than 0. It satisfies. Therefore, your answer will be on the lesser than -3, right? So let me just put it, the final answer, it is -3. And then all values of x that is less than -3 will be the answer, but not including -3. So it proves the same approach of the second method. So if I'm already found that the right area doesn't satisfy the inequality, it means I can keep checking the other area since if I'm moving to the left to the first area, this is the first area, this is the second area. If I'm moving to the first area, I'm passing one border, okay, one factor, -3. Since I'm passing one factor, it means the condition change. It will satisfy. Okay, that is the quicker method. So let's go to the second example of fraction inequality. This is another fraction inequality. So now we have two factors. Okay, we can recall back before. No matter the situation is, if the factors being multiplied, like this one, the factors are multiplied. So we have three borders, and then we find the area and then test the area. It doesn't. It's almost the same if we have it division. okay, of the factors. So this one is also almost the same. Okay, notice that we have already had the condition that one side it is 0. Okay, so after we have that situation, now we can go to the factors. Okay, so now because one side is 0, then let's just have what are the zeros of each factor. For this one, it is x equals 2. From the second factor, x equals negative 3. Okay, so we have two borders here. So let's just put the border there, negative 3 and 2. Okay, but for the negative 3, since it is on the denominator, no question, it will be an open circle. It must be. As for the numerator, it depends on the inequality sign. So if the inequality sign has no equal sign like this one, so it will follow the open circle. Also, it will we use open circle since the solutions cannot include 2 itself, since there is no equal sign. Okay, so keep in mind, if the zeros come from the numerator, it will follow the inequality sign. But if the 0 come from the denominator, no questions, it must be open circle. Okay, I hope it's clear. So now let's test the area. When I test the area, I will show you the representative of each area. This one is 0. This one is maybe 3. This one is like negative 100, for example. You can do that. So let me test one of the area, which is 0. I like 0. So I put it into the inequality. It will be, if I put 0, so it will be 0 minus 2 over 0 plus 3. Is it greater than 0? That's the question, right? So negative 2 over 3. No, it's not. It doesn't satisfy it. So it's not the answer. Since we know it's not the answer, so let me just skip the testing area, test the other area. So let me use the method of from here. If I go to the left area, I'm passing this factor, which is x plus 3. Since we have only one factor of x plus 3, it means the situation changed from not satisfying into satisfies. Okay, so back. Let's go from this area. When we go to the right, we are passing this area, which is x minus 2. We passing this factor, sorry, x minus 2. So since x minus 2 is only one factor on that rational algebraic expression, since before we have the condition it doesn't satisfy, it means it will satisfy. So the final answer will be, this is negative 3, this is 2. I believe, and it will be like this. So all values of x that is lesser than negative 3 and all values of x that are greater than 2 will be your solution. If you don't believe it, let us test the representative of each area. Just like, let's make this as the final proof that we can use this approach. Let me use 3. If I'm using 3, the inequality becomes 3 minus 2 over 3 plus 3 greater than 0. So it is 1 over 6 greater than 0. Is it true? Yeah, it is true. Therefore, all of the numbers from the third area will satisfy the inequality. Since 3 as the representative prove it that it satisfies the inequality. So how about negative 100, for example? Okay, so negative 100 minus 2 over negative 100 plus 3, is it greater than 0? So it is negative 102 over negative 97. Since it's negative negative, so it is 102 over 97 greater than 0. Is it true? Yes, this is true. That's why we have proven again that actually you don't have to test each of the representative of each area. You can use the second approach by doing the passing something and then changing the condition. Remember, you only change the condition if you have one factor. Later I will show you how if we have two factors. So now let's go to the next example, fractioning inequality. But one side has been 0, so that's good. But the things that we have now, the condition, we haven't factored completely the polynomials on the left member. So let's just, before we go to find all of the borders, let me just show you how that we need to factor it first. So this one, it will be x minus 13, x plus 3. Okay, so less than equals to 0. Now we have all being factored completely, And we have total 3 factors. On the numerator, we have the 0 x equals 2. On the denominator, x equals 13 and x equals negative 3. So we have 3 borders now. Okay, let's just put all of the borders. This is negative 3, and then we have 2, and then we have, sorry, the 2 is not, we have 2, and then we have 13 approximately. Okay, so since from the numerator, the 0 will depends on the inequality, because the inequality has an equal sign here, it means 2 can be your solution also. It means we use closed circle. As for the zeros from the denominator, out of questions, despite of the inequality sign, it always be an open circle. Since they comes from the denominator, you cannot use x equal negative 3 as your solution. You cannot use x equals 13 as your solution, since it will make your inequality or expression becomes undefined, right? So we have now 3 borders. So I know that we have 3 borders, and I have 4 area, right? 4 area. I want to show you this is the border, this is the border, and this is the border. So 4 area total. So let's check which areas that satisfy the inequality. So for the first area, I know that I can use negative 100 as my representative. From the second one, I can use 0. From the third one, I can use 5, for example. And for the fourth one, I can use 100. Okay, now I just want to check one area to make it quickly. So quicker, to make it quicker, sorry. So if I use 0, okay, I use 0 as my tester. That's the number. And if I use it into the inequality, I will have the inequality statement becomes 0 minus 2 over 0 minus 39 less than equals to 0. Okay, it means negative 2 over negative 39 less than equals to 0. So it is 2 over 39 less equals to 0. Is it true? No, it's not. Therefore, I know this is wrong. Now I want to use the second approach, which I don't want to test each of the numbers, since from the second area, if I move to the left to the first area, I'm passing one factors, which is x plus 3. This is only one factor, right? Only one total on the left area. So it will satisfy. Okay. And then if I'm moving from the second area to the third area, I'm passing one factor, which is x minus 2. Okay, it must change the condition. It must satisfy. And then from the third area, if I'm moving to the fourth area, I'm passing one factor, which is x minus 13. So since I'm only passing one factor or from satisfy condition, it won't satisfy. So in the end, I can be certain that the solution will be all values of x that is or that are lesser than negative 3, and then all values of x that are greater and equals to 2 but less than 13. It is the solution. Okay, so that's how you do it. It's simple actually, and you can try to test. You can try to check whether this is correct by testing all of this. But since I have already proven my statement from the previous examples, that actually I don't have to test each of these representative. Instead, I'm using the approach of moving like this one. I want to show you this example by using the testing of each of the numbers. Okay, so let's go to the next one. Yes, we have already had the situation that one side is 0. So let's just factor completely all of the polynomials that we have. On the numerator, it has been factored completely because we have only one factors. How about the denominator? So the denominator there will be 2 factors since this is a quadratic. So it will be, what is it? Negative x minus 3, greater than 0. So actually we have 3 factors total, but only 2 zeros. Why? Because from the first factor we have the first 0 is negative 12. And from the second and the third factors we have the same zeros, which is 3. So actually we have only 2 borders, although the factors are 3. So now let's just put all of the borders here, negative 12, and this is 3. Okay, so obviously from the denominator, we have to use open circle. But from the numerator, it depends on the inequality sign, sorry. If there is no equal sign, it means we also use open circle. Okay, because negative 12 cannot be your solution. So now let's just test the area. So we have 1, 2, 3 areas. And from the first one, I will just check this. From the second area, I have 0, okay, as my representative. From the left area, I have negative 100. I like to use 100. It's easy to calculate. And on the third one, I use like not okay. No, not 100. That is not a good move. Let me just use negative 10 instead. Okay, negative 10. Not negative 10. I can use negative 20. Let me just use negative 20 here, and this one is 10. Okay, so if I'm using 0, testing to the original inequality, I will have the statement 12 over 9 is greater than 0, which is correct, right? It means it must satisfy the inequality. So now let me just pretend that I don't know the other areas. Let me use the representative of the first area, negative 20. So if I'm using negative 20 into the inequality, it will be negative 20 plus negative 8 over, this will be 400 plus 122 plus 9 greater than 0. So in the end, it's negative 8 divided by a positive numbers. It will be greater than 0. Is it correct? No, of course not, because it obviously will be negative. So this one is not, doesn't satisfy the inequality. How about the third one? The third one, if I'm using 10 into the inequality, it will be 22 over 100 minus 60 plus 9 greater than 0. So it is 22 over 49 greater than 0. Does it satisfy? Yes, it satisfies the inequality. So what's wrong here? Okay, so we have a different situation. So the answer is negative 12. This is 3. Okay, I'm sorry. That is not a good one. Let me just revise that. Okay, let's just do my best here. So actually, the answer is all values of x that is greater than negative 12, but also it cannot be 3. So all values that are greater than negative 12 and all, not 3 included, that are the solution set that will satisfy this inequality. So what is different than the previous one? So if I'm using the second approach, which is I'm moving from one area to the other area without testing each of the representative. So first I'm using here, okay? I'm using 0, and I know that 0 will satisfy, okay? 0 will satisfy, and I will just erase it, all of the representative of the left and on the right. So when I'm moving from the center or the second area to the left, I'm passing a factor which is x plus 12, a factor. That's why it changed. It becomes doesn't satisfy. So if I'm moving from the second to the third, from satisfy, I'm passing a factor, a 0, which is 3, but total we have 2 factors. Since we have 2 factors, not 1 factor, the situation will be the same. If the previously it satisfies, so the next one will satisfy also. Okay, so yeah, that's why it is different, because we have 2 factors now on the left. So now how about this one? We have another condition of one side has become 0, so we're good with that. So let's factor completely everything on the left for all the polynomials. On the numerator, we have x minus 10, x minus times x minus 3, okay, over this one is x minus 3, x minus 3. Okay, so, ooh, wait, we have, yeah. So the situation here is we have 4 factors total, but only 2 zeros. So the first one is 10. The first 0 is 10, which is, okay, and the second one is 3. But it is from 3 factors. So keep in mind, in inequality, I want you not cancel everything. Just leave it be. Okay, please do not cancel this one. Just leave it be. Of course, in the end, it will be the same, but the safest part is you don't cancel it. But I will explain you later why. Okay, so now if we have this situation, we have only 2 zeros, which is 3 and 10. Remember that for 10, since it is from the numerator, it depends on the inequality sign. Since the inequality sign has equal sign there, it must be closed circle then. Okay, but about the 3, of course it's quite confusing because 3 comes from the numerator and comes from the denominator also. But keep in mind, actually, if we use 3 as your to replace x, we always have an undefined or undetermined situation. Therefore 3, although it comes from the numerator and the denominator, you cannot use 3 as your solution. So in the simpler way of thinking, whenever you find a factor or a 0 comes from the factor of the denominator, it doesn't matter if it also comes from the numerator, you will have an open circle. So yeah, that's how you do it. So whenever we have zeros from the denominator, open circle always. Okay, it doesn't matter if it's the same factor is on the numerator also. So now, after we have this, let's just test the area, right? Test the area, and we have this one is 0 from the first one, the first area. We have 0 as the representative. From the second area, we have what, 5, and the third area we have, for example, 15 or 11. Okay, but now you can test it one by one, but I don't want to test it. I'm just using the second approach. So I'm using the 0. Okay, and let's put into the inequality. So I have 30 over 9. Is it greater or equals to 0? Yes, it is. Therefore, it satisfies. So now I'm trying to move step by step. So if I'm moving to the second area, I'm passing this factor, which is x minus 3. And we have total 3 factors. So if it is an odd numbers, 1 factor, 3 factors, 5 factors, the sign or the condition will change. So previously it satisfied, so the next one it won't satisfy. Odd numbers, 1, 3, 5. Okay, so now we have this doesn't satisfy. So let's go to the third area. Since we are passing a factor which is x minus 10, so it will satisfy. In the end, this is 3, this is 10, and your solution will be all values of x that is less than 3 and all values of x that is greater and equals to 10. Done. Okay, since we have dealing a lot of examples, let's do this quickly. Now, let's first we have already had one member into equals 0, so that's fine. That's good. So now let's go to the factoring. So on the numerator, I can factor it. It is x minus 10, x minus 3 over, and this one is what? It is an x minus 10, x plus 2. Okay, less than equals to 0. So now we have the situations that we have all the factors and do not cancel it. Again, do not cancel this one. No. So I want you to keep that in mind. Okay, why? Because we need to record which factors or which zeros that comes from the denominator. So now we have how many zeros total? So we have the first zeros is 10, but it comes from 2 factors. And then the second zeros is 3, and the last 0 is negative 2. So we have negative 2, we have 3, we have 10. Okay, so now because we have the situation is the inequality sign is less than equals to, okay, before we go to that, let's go to the all factors on the denominator. So all factors on the denominator is negative 2, so negative 2 must be open circle. And another factor that comes from the denominator is 10. So 10 must be open circle. No matter if, again, it doesn't matter if x minus 10 is on the numerator also. But because it exists on the denominator, it has to be an open circle since you cannot have an undefined situation. So the 3 itself, it will be closed circle. since 3 comes from the numerator and it refers to the inequality sign, it has equal sign. So 3 is close circle. So the rest will be testing the area. Again, I'm not canceling it. So let me just use I have the first area, second area, the third area, and fourth area. So whenever I can use 0, I will try to use 0. Therefore, 0 comes from the second area. So if I put it into this inequality, I will have 30 over negative 20 less than equals to 0 if I'm putting 0, right? So in the end, a negative values or numbers less than 0, so it satisfies. Therefore, it satisfies. So when I'm moving from the second area to the third area, it passes x minus 3, which is only one factor, so it won't satisfy. And then if I'm moving from the second area to the left, I'm passing a factor, which is x plus 2, so it won't satisfy. And then if I'm moving from the third area to the fourth area, I'm passing a 0, 10, but it comes from two factors. Since it comes from two factors, it means which is even numbers, it stays the same. Okay, so in the end, you can only have negative 2, and this is 3, and in between. This is your solution set. Why? Because this is the only area that satisfies the inequality. This one is not, this one is not, even the 10 is not, and this one is not. So yeah, you can put it as simple as this. All x that are between, that is greater than negative 2 but less than equals to 3. This is the final answer. And in the end, if you have a lot of factors, don't be afraid. So just do the same thing. Okay, this is the one of the extreme examples. I have how many factors? 1, 2, 3, 4, 5, 6, 7. 7 factors. Now it has already been factored completely, so we don't have to use the factorial theorem, and it has already have one member into 0, so that's fine. So let's just detect what all of the factors, all of the zeros. The first zeros is negative 1, this is negative 3, this is 5, this is 0, this is negative 2, this is negative 2, this is 7. Okay, so actually we have total 1, 2, 3, 4, 5, 6, 6 different zeros. Okay, I don't know if it's okay, this is negative 2, and then we have no, sorry, negative 3, and then negative 2, and then we have negative 1, and then we have 0, and then we have 5, and then we have 7. Okay, so let's go to the denominator. So all zeros comes from the denominator, must be open circle. So this one is open circle, right? Okay, that's not a good. So this one is open circle. Let me just do this. And this one is open circle, and this one is open circle. Okay, and how about the numerators? Because the inequality sign has equals, so all the zeros from the numerator, it is close circle, and close circle, since it can be one of your solution. So the rest will be testing the area. Again, look how frustrating it is if we have to test all of the area, since actually we have 7 different areas. We have 7 different areas, right? And of course, for this one, this particular situation, we cannot use 0, since 0 is one of the border, so we cannot use 0 here. So let me just use 1. Okay, 1 is coming from the 5th area. Okay, 1 comes, so let me just use this one. This as the border, this is a border, this is a border, this is a border, this is a border. Okay, so 1 is comes from this area, so let me put into this one. So it will, I will put into this inequality, so it will be 2 times, if I putting 1 into the x, 2 times 4 times negative 4 over 1 times 3 times 3 times negative 6 less than equals to 0. This is positive, this is positive, this is negative, positive, 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 negative. Actually, the final answer must be positive, right? Less than 0. Is it true? No, it's wrong. Since all negative is that is the one who less than equals to 0. You can see that actually I'm just keeping multiplied in numbers, since it's spending a lot of time. I'm just referring to the sign here. But if you don't get what I mean, so let's just multiply it. So 2 times 4 times negative 4 is negative 32. over 1 times 3 times 3 times negative 6 is negative 54. So in the end, I have 32 over 54 less than equals to 0. This is positive. This is positive. So actually, you can skip using the numbers. Just focus on the signs. Okay, so you can have a faster one. So it doesn't satisfy. It means so this one doesn't satisfy. So from the first from the fifth area, okay, from the fifth area, not this is. I'm now moving to the right. If I'm moving to the right, I'm passing this factor. Okay, x minus 5. X minus 5. The total factors on the left is 1. So it's changing. It will satisfy. And then from here to the seventh area, I'm passing 7. X minus 7, only one factor. It means it doesn't satisfy. And then from the fifth area to the fourth area, okay, I'm passing 0 here. And 0 has only one factor. So it will satisfy. Changing. From the fourth area to the third area, I'm passing negative 1. Negative 1, only one factor, this one. So it will not satisfy. And then from here to the second area, I'm passing negative 2. So negative 2 comes from factors x plus 2. We have 2 here. Since we have 2 factors, which is even numbers, so it will stay doesn't satisfy. So previously doesn't satisfy, so it will be another doesn't satisfy. So from the second to the first one, I'm passing x plus 3, which is only one factor, so it will satisfy. Okay, so in the end, we can draw a conclusion that this is negative 3, and then the one that is satisfying is this one. It is negative 1. This is 0, and then 5, 7. So all values of x that is lesser and equals to negative 3, and all values of x that is between negative 1 and 0, but on a negative 1 is included, and all values between 5 and 7 and 5 is included are your solutions. Okay, that is your final answer. That's how you do it. So hopefully this explains how, but the case is sometimes we have problems that we still don't have this situation, which is all has been factored completely and one side has become 0. So this is the last one that I will show you, and I will tell you the steps how to solve fraction inequalities. So this is the final one, and this is the real one. So actually, not all of the fraction inequalities you have already had 0 at one side. So this is one example of the complete fraction inequality. So how do we solve this? So the first objective is to make one side into 0. Okay, that is the first objective. One side into 0, or one member into 0. But the thing is, you cannot get rid of the fraction. So that is the big difference with equation. You cannot multiply all by the factors on the denominator and then done, you get rid of the fraction. No. So for inequality, again, let me remind you, never get rid of the fraction. So how do you do it? Just use the sum and difference. Okay. So let me just, sorry, what's happened here? Okay. So let me just show you how it's done. First, let me just subtract both. I will subtract both by 2 over x squared minus 3x plus 2. Okay, so in the end, it will be 4x over x minus 1 minus 5x over x minus 2 minus 2 over x squared minus 3x plus 2 is greater or equals to 0. So that's the first step. And then since we have addition of fractions, the next step is we make the same denominators for all the fractions, right? So how it's done? Just multiply each fraction. So this one I will multiply it by x minus 2 over x minus 2. This one I will multiply by x minus 1 over x minus 1. And this one, no, since if I factor it, actually this is x minus 2, x minus 1, right? So in the end, I will have the statement will be 4x multiplied by x minus 2 over x minus 1 times x minus 2 minus 5x times x minus 1 over x minus 1 times x minus 2 subtracted by 2 over x minus 1, x minus 2. Right? So let's combine everything. So it will be 4x squared minus 8x minus 5x squared plus 5x minus 2 over x minus 1, x minus 2 greater equals to 0. Okay, so let me go to the right side because I have limited area. So after I simplify it, it will be negative x squared minus 3x minus 2 over x minus 1, x minus 2 greater or equals to 0. I don't like the negative one, so I will multiply all by negative 1 on the left side and on the right side. So in the end, I will have x squared plus 3x plus 2 over x minus 1, x minus 2 less than equals to 0. So the last one I will put on this side. After I factor completely, it will be x plus 2, x plus 1 over x minus 1, x minus 2 lesser equals to 0. So this is the final statement that you are familiar with. We have already factored completely everything, and we have one side it is 0. So now let's just find all of the zeros. So for this one, we have 4 different zeros, right? This one is negative 1, this one is, this one is positive 1, positive 2, negative 2, negative 1. So we have 4 different zeros. Let's put it, it is negative 2, negative 1, 1, 2, right? And everything that, all the zeros that come from the denominator must be open circle since it cannot be the solution. So this one is open circle, this one is open circle. Okay, this is not a good open circle, so let me just revise it. Open circle, and then all the zeros from the numerator, it will refer to the inequality sign. So this one will be closed circle since there is an equal sign there, and this one is closed circle. Done. So the last thing that we need to do is testing the area, but I will do the second approach again. I just want to test one area, which is this one is 0. This one is 0, right? 0 is here, so I will test this area. So if I put it into, I can put into this, so whatever, since we haven't modified anything, we just do subtraction and we don't cancel anything, so it's fine that we use the last one. So if I use 0 here, I put 0 into this inequality, I will have positive 2 multiplied by positive 1 over 0 minus 1 is negative, 0 minus 2 is negative. Negative times negative is positive, so it will be positive over positive. Positive, is a positive is less than equals to 0? No. Since it is not satisfying, it doesn't satisfy the inequality. Now I will use the moving thing. If I'm moving to the right side, I'm passing one factor, which is x plus 1, so it must satisfy. And then from here, by moving to the right, I'm passing one factor x plus 2, so it won't satisfy. So go back to here. If I'm moving to the left, I'm passing x plus 1, which is only one factor, so it will satisfy. If I'm moving here, I'm passing one factor, which is x plus 2 here, so it won't satisfy. So the final answer will be all values of x that are between negative 1 and negative 2 inclusively, and all values of x that are between 1 and 2 exclusively, since 1 and 2 is not included. So that's how you do it. So that is how you do fraction inequalities. So again, keep in mind that first you need to make one side into 0, but never get rid of the fractions by multiply everything with the factors on the denominator. Never do that. Just keep it on fractions. And then if you can cancel a factor or two because they have the same factors on the numerator and denominator, never do that. Just leave it as complete as possible. So because, let's go back to like this one. I leave it as complete as possible. I don't cancel x minus 10, x minus 10. No, leave it. Okay. And then, I have also the same thing on the previous. But again, just leave the factors as complete as possible after you simplify it after you combine everything into fraction over fraction. So yeah, that's how you do it. I hope these examples and explanations help you to do the fraction inequalities. Of course, you need to practice so you can master this. Happy practicing.